And yeah, okay. So when it comes to rotation of axis, just understanding from the term itself, rotation of axis, what this simply means is that it's a situation where, let me use an ellipse for as an example before I even start deriving any formulas, equations, or anything. If this is our xy plane, okay, this right here is our xy plane where I have that as my y-axis and I have this as my x-axis. So what it is that if, let's say, I have an ellipse centered at the origin. Let me say I have my f1 right here. Let me say I have my f2 right here. Then here, let's say you have your v2, which is your second vertex. Then here, let's say you have your v1, like that. So if you have an ellipse that is drawn in this way, okay, I'm just trying to use this as an illustration of what we mean by rotating these axes. So what it is that these that we have right here, um, the y and the x are our original axes. So there are cases sometimes where you'd want to rotate the axis, such as you have a new axis, because if you look at the way it's drawn, okay, the angle here is basically 0 degrees. Okay, you can use 0 degrees, you can use 360, still going to give you one and the same thing. But there are times when the the conic section itself is rotated. Okay, so let me just try to highlight everything and rotate this same one. So what I mean is that, look at the way it is right here. You're able to, that's our y-axis and that's our x-axis. So I would want to sometimes rotate it. Maybe it appears like that. Okay, uh, it appears to be something like that. So what I mean is that if I rotate it, this now is going to be my y prime and this is going to be my x prime. But take note to say it depends on who is lecturing you or which book that you are using. Sometimes in place of y prime, they can use uppercase y. Okay, instead of sometimes using x prime, they can use uppercase x. So this and that, any of those two is going to work. I like using the x prime and y prime because sometimes I forget that I'm supposed to use the uppercase y, but I end up writing the small letter y. So now rotating this is what we want to try to look at, but having in mind to say we still have the original axis. Okay, we still have the original axis. Let me put it back. We still have the original axis, which is what? Which is our y and our x. So what it means is that want to try to see what the equation, or how we, sometimes you are given, in most cases you are given an equation, then you have to kind of like, when you rotate, you are going to have an angle from the equation, that angle theta here. So remember to say, before it's rotated, the theta is equals to 0. Okay, the theta is equals to 0, but when you rotate it, the theta is equals to some value k, which is in degrees. Okay, so this is what we want to try to look at. So before I even maybe go any further, remember to say, when you're looking at the standard equation of a conic section, the standard equation of the conic section is given as a, okay, the standard equation of the conic section is given as ax squared plus cy squared, okay, plus dx plus ay plus f is equals to 0. So let me ask you this question. Is there anything alarming that you're able to observe from this standard equation here? Sorry, the general equation, not standard equation. Is there anything that seems suspicious, something that you feel is not supposed to be there, or something that's supposed to be there but it's not here? Is there anything that you're able to observe? Anyone?
There's a letter that's missing there.
Which is?
The B.
Okay, so if you observe, I have A here, I have C, I have D, E, F, and I'm missing the B. the b is missing. So what one thing that you observe is that your a corresponds to x squared, then your c corresponds to y squared, your d always corresponds to what, to x, your e corresponds to y. It's just more like those are the coefficients for these. Then one thing is that you don't have a b term, and it's so obvious to say when you look at this, the x is on its own, the y on its own, the x on its own here, the like each variable is on its own, whether it's squared or whether it's to the power 2 or to the power 1. So that tells us to say the b is supposed to represent the combination of both the x and the y. Okay, so when you're given an in originally, if if the conic section is not rotated, the b term is equals to 0. That's something that you always have to keep in mind. If the conic section is not rotated, the b term is equals to 0. So it's that thing whereby you can write it as a squared, I mean ax squared plus, you say bxy plus cy squared there plus dx plus ey plus f is equals to 0. But this term is in most cases 0 because the conic section is not rotated. Okay, so now what we want to try to learn is how to rotate, because when they say rotate the axis of a conic section, what you're trying to do is to get rid of this b term that you have here. When you have gotten rid of this b term here, you're going to remain with this general equation. From that general equation, you can complete the square. After you complete the square, you'll be able to tell what type of conic section you're dealing with. Is it a circle? Or is it a parabola? Is it a hyperbola? Or is it an ellipse? Because the way it is right here is quite straightforward. I can even use the discriminant test to try to tell what type of conic section that I'm dealing with. Even right here, you're able to tell using the discriminant test. Okay, so we're going to be having such equations with a b term. Then after we rotate it, the goal of rotation of axis, all the stages that you'll be going through, it will just be to eliminate this one here, because you can't complete the square in the form that it is. So the goal of rotating the axis is just to eliminate this this foreign term that we have here, which is our what, our bx term. Immediately you manage to rotate, just not to say you have answered the question. And for me, usually, I don't like sometimes the fact that I get lazy, because when I'm rotating a conic section, immediately I manage to eliminate the b term. I even feel lazy to sketch the graph, because I feel like I've already succeeded. Like, who can fail to sketch the graph if they already managed to rotate? Because more like when you rotate, to eliminate is what is slightly complicated sometimes if you don't know how to go about it properly. Okay, so there are some things that I'm going to leave out, because I know they can't ask you to show how you derive all the equations. Okay, but there is a video that I made about deriving all the equations. I just feel like if I go through the entire process, it might take time, unless if you want me to. But I can give you the necessary details that you need to answer any question regarding rotation of axes. Okay, so I don't know if you feel like I should go through all the derivation and stuff, or but that would be very long, I think. Okay, so here there are, when it comes to rotation of axes, there are four most important equations that you should always keep in mind. There are times when you are given a standard equation, such as what example can I give? They would give you an equation that is not rotated. Okay, let's say it's given the same one as let's say it's ax squared plus cy squared plus dx plus ey plus f is equals to 0. This one is not rotated. Okay, and there are times when in fact, let me include the b term, which is our bxy. Then I say plus cy squared plus dx um, plus ey plus f is equals to 0. So let's say for example this one that we have is not rotated. Okay, let's say it's not rotated. How do you then rotate it to get rid of this b term? So keep in mind, there are times when you are given an equation that is rotated, then you take it back to the way it was originally. And there are times when you are given just a basic equation, then you rotate it. So it's either maybe it was something like this, okay, then you rotate it such that it goes like that, or it was like this initially, it was rotated according to the equation, then from that you do what? You take it back like this. So always keep that in mind. Those are just the major two instances. There's one that is rotated and one where it's not rotated. Okay, so let me give you four those four equations. So for this part, let me say here when it's rotated, then here when it's not. Okay, so the four major equations is when it's rotated, then when it's rotated and you want to get it back to the way it was originally, here are the four equations that you're going to use in place of x. And don't worry about all this, I'm going to try to give an example. So you are going to substitute, you're going to say your x prime will be equals to um, x cos theta plus what? Um plus y sine theta. So in that video that I made, I explained where all of this is coming from. Of course, in the paper, I don't think they can ask you to derive this. It's very easy to derive, but I doubt if they can ask you to do that. Then your y prime will be equals to um, it will be equals to minus x to be equals to minus x sine theta plus y cos theta. Okay, so when it's not rotated, meaning it's just like this, then you're trying to rotate it, like maybe it goes in that direction, or it can even go in this direction depending on the angle that you have, whether it's positive or negative. You're going to have your x equals b equals to it will be your x prime cos theta minus y prime sine theta. Then your y is going to be equals to your x prime sine theta, okay, plus y prime cos theta. So these right here are the four most important equations that uh, you should always keep in mind when you're rotating the axis. They are the ones that you need. So the question is, you just have to, okay, the thing is, you just have to know to say, okay, is the equation that I have, is the general equation that I have, is it rotated or is it not rotated? Okay, and in the question they would tell you. But if it's silent, take it as if it's not rotated, then use these ones. But sometimes they would specify to say it's rotated, then even the way they would write the general equation, it would tell you, because if it was rotated like the way it was like that, maybe the general equation is going to be something like a capital X squared plus you're going to have b capital X by y plus c capital Y squared plus that's going to be dx, then you're going to have plus um, ey plus f is equals to 0. And one thing that is clear is the fact that here, of course, I've said you can either use capital letter X or x prime is still one and the same thing. So that this is what it means, where where you have x squared, you're going to substitute with what? You're going to substitute with this one here, such that you're going to end up with your x and your y, and that will take you back to the original equation the way it was. But if it's not rotated like the way this one is, when you substitute where there's x, for example, let's just say this was lowercase x, when you substitute here, you're going to end up with what? With this one here. Hence it will take you to what? To x prime and y prime, meaning you have rotated it. But you should always take into consideration the angle that you are dealing with, because you're not supposed to you're not supposed to draw the conic section that you want to draw like every other conic section. Let's say for example it was not rotated, then you come back and still draw it like this. Let's say it was an ellipse. That's going to be wrong. If it was rotated, let's say at an angle of what, of 45 degrees there, let's say this is 45 degrees, you need to draw another what, another xy plane at an angle of 45 degrees from this one here, such that you're going to draw it like this. Okay, so that's why I'm saying always take into consideration the angle. There are times when you're not rotating counterclockwise. Sometimes it's easy clockwise, coming down like this, depending whether the angle is positive or negative. If it's positive, it's usually going counterclockwise. If it's negative, it's always clockwise. Do you have any question up to this point?
No.
Come again?
No.
Okay, so if you observe, I've been writing cos theta, sin theta, like everywhere here. You might want to ask to say, where is the theta? How are you going to come about, how are you going to get your theta? So how we get our theta is very simple. Okay, how we're going to get our theta is very simple. It's either you can use cot or tan. So cot is kind of like the common that they use to come up with the angle. You're going to say it's going to be cot 2 theta equals to what? Um, Equals to A minus C divide by B. Or you can write, instead of cot, you can use tan. Tan 2 theta is going to be equals to B divided by A minus C. Okay, so if you are familiar with trig identities, you know to say cot 2 theta, or let me say cot theta. Okay, cot theta is nothing but what, 1 over tan theta. So if here I substitute, I say this is equals to A minus C divided by B. If I make tan theta the sub of the formula, this is just going to end up to be what? It's just more like you're going to multiply. If like from this point I multiply both sides by what? By tan theta, then I also multiply both sides by what? By B over A minus C, such that I'll cancel this one and that one. You're just going to end up with what? With this one here. So this right here is how you come up with your angle. Is that okay?
Yeah.
Yeah, but always keep in mind to say there are times when your angle is not perfect. What I mean is, I believe by now you are familiar with special angles such as 60, 30, and 45. Okay, these are pretty simple. You can, you know special angles by now, I believe. Okay, but there are times whereby, let's say you divide, um, you don't get something that's pretty perfect. Let's say you get something like let's say 3 over 4. Okay, you can't get this from special angles. And what I mean by not being able to get it from special angles is because there are just some values that are so close to special angles. They are closely related to special angles, such as if you say this is 1 divided by 1, this will give you what? It will give you 1. Okay, and if you go to special angles, the angle that's going to give you a 1 is what? Is 45. And that is when you have what? You have tan what? um, Tan 45. You're going to get a 1. So what it is that, what is 45 in terms of radians? Is pi over 4, right? Because 90 is pi over 2, so divide this by 2, you get 45, and that's what you're going to use. So as I said, there are some cases where you don't end up with some perfect angle such as 45 or maybe 30, because I think 30 is it, pi over 6, I think so. Yeah, so you might not get 45, we might not get 30 here and there, but there are times when you can get something like, I'm giving an example of 3 over 4. And what it is here is that if you want, um, to make your work simple, even if you get a 1 right here, okay, even if you get a 1, you're going to ask yourself, what is going to be tan 1? Sorry, what's tan 1 actually? Tan inverse of 1? If, for example, I divide here, then I end up with a 1. So meaning I'm going to say tan 2 theta is equals to 1. Then I want to find what my theta is. You're just going to say this is tan inverse. I mean, theta will be equals to tan inverse of 1. What's tan inverse of 1? Anyone with a calculator there?
I don't know if it's correct, but I think it's 45.
Yeah, it's supposed to be 45. Let me just confirm. Exactly, it's going to be 45. So now, to find what your theta is, you're going to have to divide it by 2. So now what it is that when you say tan inverse, I mean 2 theta is going to be equals to tan inverse of 1, I found that is 45. Don't write 45 like this. Put it in radians such that you know that 45 is equals to pi over what? Pi over 4. So meaning, try to determine what your theta is. Your theta is just going to be equals to pi over what? Pi over 8. Like that. Okay. So now, what do you do if you are faced with such an instance whereby if you say tan inverse of 3 over 4, you're going to get something like 36.86. Then if you divide this, not dividing it by 2, okay, can divide by 2, you're going to get like 18 point. So what you do, you don't want to use values that are going to give you decimal places. That's why, like, I'm trying to use this one as an example. So the question is, what do you do? Okay, what do you do? So what you do in this case is that you have to remember some trig identities, and they are called half angle identities. Those are where it's a situation where you're going to say your sine theta is equals to, just going to be equal, supposed to be positive or negative, but you're just going to use the positive part of it. Okay, that would be the square root of, if you have a PDF of trig identities, you just check where you have a half angle identities, you're going to see this. So this would be 1 minus cos 2 theta there. Then your cos theta will be equals to your 1 over 2. Then that will be 1 minus, no, no, I mean 1 plus cos 2 theta, like that. So these right here, you can use them even when you are getting perfect values such as a 1 or anything that you're able to work with. So this is what you use to find sine, this is what you are going to use to find cos. So now, this might seem confusing at some point, but it's very simple. If you have cos 2 theta, the question is, how do you come up with cos 2 theta? For example, if I end up with this as my what? As my, let's say I end up to say my cot 2 theta is equals to what? Is equals to 3 over 4. I can write this in terms of tan. I can say, okay, instead of me using cot, I know what tan is. Tan 2 theta is just going to be equals to the reciprocal of that, which is going to be what? 4 over 3. Then I want to determine what my cos 2 theta is from this tan 2 theta. And it's very simple, guys. You're just going to see, okay, these two values are positive. So meaning I'm looking at the first quadrant here, like that. So this angle that I have here is what is called the what? The 2 theta. And you know to say from SOHCAHTOA, tan is equals to opposite over adjacent. And this is your opposite, which is going to be your 4, and your adjacent is going to be what? 3. Then I believe what you're going to have here is a 5, because this will be 16 and that will be a 9 when you square them by Pythagoras theorem. You're going to end up with 5 there. Then what will be your cos? Cos is this one, the adjacent divided by hypotenuse. So you are going to come and say, okay, my cos 2 theta is equals to my adjacent, which is 3, divided by the hypotenuse, which is also what? Which is 5. Which is a 5 right there, like that. Then you're going to come and substitute here. For example, if you want to find what your sine is, you come and say, okay, this is going to be the square root of 1 over 2. Then that would be 1 minus cos 2 theta. You substitute with what? With 3 over 5. Then you find what your sine is, such that when you are rotating, you come here where you have sine, substitute with whatever you get here. Okay, where you have cos, substitute with what you get there. Is that clear, friends? Is that clear?
Yes.
Yeah, I hope so. So let me. Your tutorial sheet is out. Does it have questions on rotation of axes? Or let me. Okay, let me try to use last year's paper. I think I have it.
Yes, it does.
Okay.
Mm, question done.
Okay. Let me just start with last year's paper. Where is it? Uh, and by the way, we have a website. If you have ever attended tuitions for first year under Transcended Institute, not engineering, I believe you are aware that there is a website. So we have added courses for Beng 2 on the website, and even some. I'll be making some videos for math as well, and I'll be uploading on the website. Meaning, sometimes you don't really have to wait for a class or something. You can just, if you're registered, you can just go and watch the videos on the website. So I'm hoping I can start uploading the videos as soon as possible, and I will try to inform you immediately that is ready.
For the question,
Yes.
for the other questions, will you also be teaching those or just math?
Um, for triple E, yes, I will be tutoring. Then for CEE, I have a colleague who is supposed to tutor, but he's not available at the moment. Okay, for CE, it's just because there is no demand. That's why we are not tutoring in CE. Yeah, but for other courses like even drawing I can only help you if you have an assignment, but I can't tutor you. It's just too involving. It does a lot. Those who have ever done drawing, they'll tell you. It's not hard, but it just has a lot to do. It consumes a lot of time sometimes, more especially if you have never done drawing before. So I can only help with an assignment for drawing, but I can't sit down to start tutoring. You can just tell me when you have an assignment, then I can assist you if you need assistance.
Okay, so you only do math, CE, and triple E.
For now, yes. For now, of course, it's just math and triple E. C we can do. We are ready to do, provided there is demand. But I know there will be demand after test one.
Okay.
Yeah. Okay. So I have found the question. So last year's question was actually very. In fact, it was 10 marks. Yeah, it was 10 marks. So it is saying identify and sketch the conic section given by this equation. So they would not tell you that rotate, they would just tell you to identify. And because of knowing the fact that anytime you have a bx term, if you have a bx term in a general equation, that tells you that you are supposed to rotate. So what it is here is that you have gone, the equation that is given is 4x squared minus 4xy plus 7y squared minus 24 is equals to 0. So one advice that I'm going to give you is that as you are able to see this one, this is not rotated, and don't make an assumption that it's rotated, because if, instead of, if you look at these equations that I've just erased here, let me try to bring them back. If the equation that you are given is not rotated, then you use this, it's not going to work out. You're just going to waste your time. And again, if it's rotated, then you end up using this, it's not going to work out. So try to identify first of all the equation that you're given. Is it rotated or is it not rotated? And I say if it is silent, they have not told you it's rotated, just take it as if it's not rotated. And it's the similar thing with this question that we have here. They have just said identify. Okay, and actually it's a rare case where they give you one that's rotated to take it back. Sometimes in most cases they give you one that is not rotated, which is this one here. 4x squared minus 4xy, which is our b term there, plus 7y squared minus 24 is equals to 0. So what I would want to do to make this fun for you is I would first of all want to identify what type of conic section that I'm dealing with, and what I can do is to use the discriminant test. So when you're given a general equation, sometimes it's not always that you're supposed to rotate it, because there are some general equations that don't have the b term, so you're just supposed to complete the square. So before you even do that, if that's the case, you can use the discriminant test, try to identify um, the conic section before you even do anything. At least it's going to give you a picture even before you start sketching, because if I know I'm dealing with an ellipse, then I end up with a hyperbola, I need to get back to my drawing board. It would be like an indication that I might have done something wrong somewhere. Okay, so do we know how to use the discriminant test? Do we know how to use the discriminant test? Hello? Okay, um, here's how we use the discriminant test. It's written as b squared minus 4ac. Okay, minus 4ac. So now let me write it three times actually. You have your b squared minus 4ac, and take note to say it's just the parabola, the ellipse, and the hyperbola that you rotate. You can't rotate a circle. If you would rotate, okay, you can rotate, but it's a rare case where they give you a circle, because it's difficult to see that a circle has been rotated, because no matter how you put it, it's always going to appear to be a circle, unless if it's in 3D maybe, but again, unless if it has different colors on the surface in 3D. So for AC here, so there's a time when this arrangement here give is equals to what, is equals to 0, and there's a time when this arrangement is what, is greater than 0, and there's a time when it is what, less than 0. So now take note, if it is equals to 0, the conic section that you have is called the what, the parabola. If it is greater than 0, you're going to have what, the hyperbola. If it is less than 0, you're going to get what, you're going to get the ellipse. So let's even identify right now what you're going to get. So what you should keep in mind is that this is your A, that's your B, that's your C there. So we're going to come, what's our B? You're going to put B squared. Our B is minus 4 squared minus 4. What's our A? It is 4. What's our C? It is 7. Is equals to what? So that's going to be 16 minus that's 4 times 4 times 7, that's 112. So what do you get? You say minus 16 minus 12, sorry, minus 16 minus 112, you get minus 1, no, you get minus 96, of which this falls under what, the ellipse, isn't it? So whatever that we do here, we should expect to get an ellipse. If we don't get an ellipse, just know that, say, we have done something wrong somewhere. And I urge you to participate. I'll be asking questions, and if you observe anything wrong in what I've done, because sometimes it's just too much work to do when it comes to such that it's very easy to make a mistake. That's why you have to be very patient and calm while dealing with rotation of axes, more especially when you're multiplying some numbers, you're expanding. Just try to relax. Yeah, but of course keep in mind that time is moving. Okay, so now first things first, determine the angle. You're going to come and say cot 2 theta is equals to your A, which is your 4, minus the C, which is the 7, divide by the 3, sorry, divide by the b, which is minus 4. This is going to be minus 3 divided by minus 4, giving us 3 over 4. It's a similar case from what I was giving as an example. So meaning our tan 2 theta is equals to 4 over 3. You can write your triangle like that to get what your cos is going to be. So if your opposite is 4, your adjacent is 3, meaning this is going to be 5, because this will be like the hypotenuse is just going to be equals to the square root of the opposite squared, which is 16, the adjacent squared, which is 9, giving you the square root of 25, which is just equals to 5. Okay, then of course this is our 2 theta there as the angle. Then you need to tell me what your cos 2 theta is. Your cos 2 theta is equals to 3 over 5. If you observe, if I would want to attempt, first of all, before even go through this process, sometimes attempt to say what can you get here. If you try to say 4 divided by 3, that is 1.333, which is just 1.3 bar, then shift tan inverse, that's going to be 53 point something, then divide by 2. You have something that has decimal places, and you can't use that. You don't use that when it comes to such. So I prefer to use this method for now because I'm getting something with a lot of decimal places. So now it takes me back to half angle identities. Remember, we said sine theta is just going to be equals to the square root of 1 over 2, then that would be 1 minus what is our cos 2 theta is 3 over 5. And what do we get? That's 1 over 2, then that's going to be if there is 1 here, that's going to be 2 over 5, giving us 1 over the square root of 5. Is that correct? Is that correct?
Yes.
Okay, so for cos, it's just this is going to be 1 plus cos 2 theta, which is 3 over 5. This portion here I get 8 over 5, which is going to be 4 over 5, meaning that would be 2 over the square root of 5. So you can try to do this step by step. You're still going to end up with these two. So now I have the keys to everything that I want. So I found that my sine theta is equals to 1 over the square root of 5. Then you can also, if you want, you can conjugate this, because if I want, I can write this as the square root of 5 divided by 5. Don't get surprised, this and that means one and the same thing, but I'll leave it the way it is for now. Then our cos theta is equals to 2 over root 5. Okay, so now let's get back to those among those four equations that I gave you. We pick two. Those two are when it's not rotated, because we want to substitute where there is x with what our x is going to be, and we said our x is just equals to what? Is just equals to x prime. But take note, this, if you want, you can use uppercase x. It's up to you. For me, I'm using x prime, and yeah. So this is going to be x cos theta minus y prime sine theta. So you come and say your x is going to be equals to, what is your cos? Your cos is equals to that there. So just substitute. That's going to be 2x prime over the square root of 5 minus, what's your sine? Your sine is 1 over root 5. That's going to be y prime over the square root of 5, like that. And this right here, I can put it right here. I'll use it. So let me look at what my y is. So my y, we said our y is equals to um, x prime sine theta plus um, That's y prime cos theta. That's y is just to be equals to our sign is 1 over root 5. That's going to be x prime over square root of 5. Then that will be plus 2y prime divided by the square root of 5, like that. And one thing that sometimes tells you that you are doing the right thing is if you use these half angle identities. And if you observe, I have root 5 and root 5 here, it becomes very easy for me that I'm going to eliminate it at some point. That's more like those things that gives you at least some confidence that you're doing the right thing. Okay, so now here is the part where there is some work to do. You're going to come and say 4 open bracket, you put your x. What is your x? Your x is this one here. Okay, I bring it right here like that, and it is what? It is squared minus 4 open bracket, you put your x again. Okay, you place it right there. Just a minute. Like that. I close, I open again, then I put the y, which is this one right here. Then plus 7. Then I'll try to put the y in here. I'll square it. Then this will be equals to positive 24. I'll take it on the other side. Like this. So now it's just a matter of expanding. Okay, so I advise you to say to take it easy on this part. This question is time consuming, but just try to take it easy. So expanding this one, this part here, what are you going to get? That's going to be, first of all, you're going to have 4x prime squared divided by 5. Then I'll write plus. You're going to have y prime squared divided by 5. Then you're also going to have something like minus 4x prime y prime divide by 5. Then you close like that. Is my expansion okay there? Is my expansion okay there? So this one by that one, you're going to get 2x prime y prime, that would be minus actually, divide by 5. Then again this one by that one, you're going to get minus 2x prime y prime. Oh yeah, I'm right, it's okay like this. Okay, so you go to the next one, which is minus 4 open bracket. This one multiplied by this one, you're going to end up with 2x prime squared divided by 5. Then let me multiply this one times this one in advance. I'm going to get minus 2y prime squared divided by 5. Then this one by this one here, you're going to get 4x prime y prime divided by 5. Then this one by that one, you're going to get minus x prime y prime divided by 5, and that's just going to give you 3x prime y prime divided by 5, which is it positive, negative? It's positive 3x prime y prime, like that, divide by 5. Then you close, then plus. On this portion, what are you going to get? That's going to be 7. That would be x prime squared divided by 5 plus 4y prime squared divided by 5, then that would be plus 4 um, x prime y prime divided by 5. You close, this will be equals to 24. If you observe, this one and that one are similar, just that this one has a negative because you had a negative there. Okay, so now you can expand them. So this is going to be 4 by 4, that's 16 x prime squared divided by 5, plus that's going to be 4y prime squared divided by 5 minus 16 x prime y prime divided by 5. That would be, this is going to be minus 8x prime squared divided by 5 plus 8y prime squared divided by 5. Hope you're seeing what I'm doing here. Then that would be minus 4 by 3, that's 12x prime y prime divided by 5. Then that would be plus 7x prime, sorry, x prime squared divided by 5 plus, that's 7 by 4 is 28, y prime squared divided by 5. Then that would be plus 28 x prime y prime divided by 5 is equals to 24. Any questions up to this point? Any questions up to here?
It's clear.
Okay, so now one thing that you observe is that if you try to, whenever you reach this stage of the expansion, then try to focus your attention on the xy term, this one and that one and this one right here. If you observe to say this one is positive, it's more like, look at the coefficients that you have. You have minus 16, minus 12, plus 28. What does this give you? What do you get there? Minus 16 minus 12 is minus 28, huh?
Yes.
Yeah. So it appears we were successful on eliminating the b term, the b, which is the x. This one goes, that one goes, and that one goes, meaning we remain with our standard equation. And if you observe here, I can add up the x squared, which is this one here, and another one there. Then including, I can also add the y term, which is this one, that one, and this one. So I have 16 for the x minus 8 plus 7. I'm getting 15 here. I'm getting 15 for the x squared. I'm getting 15x x prime squared divided by 5, which is just simply 3x prime squared, because I have like 15 divided by 5, and 15 into 5 is 3. Then look at the y. The y is 4 plus 8 plus 28, which is 40. 40 divided by 5 is 8. So that's is it plus or minus? It's actually plus. So that's plus um, plus 8 y prime squared is equals to this one here, which is our what? Which is our 24. So what do? Write the standard equation, multiply both sides by 1 over 24. So this would be 3 into 3 is what? Is 3, then 3 into 24 is how many times? It's 8. So this is just going to give you something like x prime squared divided by 8 plus 8 into 24 is 3 times. That's 3 times. That would be y prime squared divided by 3 is equals to 1. What conic section has this equation? and that's what we got when we use the discriminant test. So from here, just you know that the center will be at the origin. Find what your focus is, find what your vertices are, find out what your co-vertices are, then sketch. So what we are from doing right now, like the rotation, you do all those things, is the most important part of rotation of the axis. So that's why I was saying, me sometimes I get lazy. Anytime I see me canceling these like this, I even feel lazy to complete the question. Like I just leave it because I know I'm already successful in like canceling out and all those things. So you have told me there are questions from the tutorial sheet under rotation of axis, yeah?
Yes.
Okay. Um, so I'm going to upload this class and I'm going to share it. If there's some that you have not understood, you can either ask me or you can go through the recorded session. Then try to attempt a question, a question or two from that tutorial sheet. Then see if it will work. If you feel you need guidance on how to go about it, maybe I've forgotten, you can either watch the video again, this particular one that we had that we are from having, then or you can come to me. I'll be able to assist you.
All right. Thank you.
Yeah, so on the next time you're going to have the next time you're going to have math will be on Monday. There is a timetable. We are those you who are new, we have math on Monday, Wednesday and Friday. Then during the weekend, either tomorrow or Sunday, we'll try to have a session so that we go through those some questions from your tutorial sheet and everything that we have covered so far. So the next time that we are going to meet, we'll try to look at it's either okay. I'll try to think about whether I'll look at parametric equations or polar equations, but I think parametric will go first, looking at the arrangement of your tutorial sheet.